No, it don't! No, it don't!
0. Okay. I want to do a quick review first. Review. And in order for you to next part, you need to know your absolute values like that. Absolute value 2x plus 6 and absolute equals to 8. Start. Solve it. I want case 1 and case 2 and write down when it occurs. That's a key. If you don't write down when it occurs, you can't do the limit of this. So I'm going to pause it. So I'm going to do this pretty quick. Really, after you have two cases, positive case. And positive case really is I leave it the way it is. 2x plus 6 equals to 8. X equals to uno. But the main thing is I need to write the statement down. It occurs when. Here's the main point. You cannot do limits until you master this point. This is greater than 0. 2x plus 6 is greater than 0. Or simply x is greater than negative 3. Okay? Nothing bad. Now I do the negative case. The negative case really means I multiply everything in there by a negative equals to 8. And I quickly solve it. You can easily solve this on your own. You don't need me to wait. So this can be negative 2x minus 6 equals to 8. And that x should equal to negative 7, I believe. And our main thing is I'm going to write down it occurs when x. Now look at my sign. Sorry. When 2x plus 6 is less than 0. The main thing I want you to focus on is the negative case. I set my inequality to be less than 0. So now this becomes 2x is less than negative 6. X is less than negative 3. Easy. But now the question lies, you must know, how do you solve this? Take what I've just taught you yesterday. We're going to apply limits to now. Lim. As x approaches 0 of absolute x, what does that equal to? Ooh. Ah. Ooh. So if I sub it in, someone say, hey, am I subbing 0? Yeah, if you sub in 0, the answer is simply 0. But again, key point. Absolute has two cases. We're going to do this again. Now I'm going to teach you how to write this as something called piecewise function. Y equals, there's actually two cases. Instead of writing two cases in separate order, we're going to write using this bracket notation. My first case is positive x. Okay? It occurs. Now instead of writing it occurs, I'm going to write down x is greater than 0. See, normally I go it occurs, but instead of writing all that stuff, I write down positive x, comma, x is greater than 0. I want you to do a second case for me, the negative case on the bottom. Okay. And who have I never aspect on before? Simon D, what's the bottom case going to be? Good. Comma, x is less than 0. We're going to use this fact, and we're going to apply this. See, this goes back to 0, and it goes to left hand and right hand approach. We're going to go lim. X, because according to the limit, it only exists when you have left hand and right hand meet together. I'm going to start with my left hand. As x approaches 0 from the left. So this becomes x. See? So now, question is, which equation do I use? The x form or the negative x form? See, this is where you got to be really careful. Sylvia, I haven't asked you before. Which one do I use? The x form or the negative x form?
The negative one?
Yep, approaching from the left. So it would be the?
Oh, you mean the x is less than?
Yep. So which do I use, the x one or the negative x?
Negative.
The negative x, good. See, if I approach 0 from the left, which means I'm using this equation. So I go negative x equals to 0. Easy. I want you to go ahead and do this thing for the right-hand side. Lim x approaches 0 from the right. So now when I approach 0 from the right, I'm using a number greater than 0. So therefore, I'm going to use this equation. See? Which is going to be very close to 0 also. So the answer is going to be lim x approaches 0 equals of x absolute equals to 0. See, I break it down into two cases, 1 and case 2. Very, very simple. Take this concept, and you're going to solve this without my help. I'm going to walk around, and I'm going to help you out this time. Lim x approaches 0. Absolute x over x. I'm going to pause it, let you have some fun with this question. I see an absolute. So right off the bat, I'm going to break this down again into two functions. For that absolute, again, instead of writing two cases, I'm going to do this. X greater than 0, x less than 0. So I go, my first case, lim, as x approaches 0 from the right. So I'm going to use the positive case, which is this one. X over x, which is equal to 1. Now some say, so what about this bottom x? How come you didn't touch it? There's no absolute value there, so I leave it alone, guys. Okay, very, very simple. I go lim, x approaches 0 from the left. Why don't you do this on your own right now, in case you didn't do it? That one. Negative 1. See, if I go, that should be negative x over x. That equals to negative 1. In this case, I have 1. I have negative 1. Look, they're not the same. So I can tell you that for a fact. Lim, as x approaches 0, of absolute x over x equals to d n e. And that's my final answer. I took a hard concept. In universities, why people fail is this. Teachers don't have time to review absolute values. They would just huck you right in, and they say half the time kids will say, how do you go from here to here? This is known as a piecewise function. I just broke it down into two separate ones. Function. And I'm going to give you more piecewise function for you to play around with. Solve this for me, please. I'm going to take this concept, I'm going to push you a bit farther and see how many you can break. Lim x approaches 4 for f of x. And f of x equals to a piecewise function. Okay. Root x minus 4 if x is greater than 4. 8 minus 2x if x is less than 4. Using what I've taught you about absolute values, I want you to take it to this question. Something I've never taught you before, but you should be able to apply it. So if I look at this question, I'm going to break this down into two pieces. Lim, as x approaches 4 from the right, f of x. Now, in this case, I'm going to 4 from right, so I'm going to use this one because it says x is greater than 4. So I'm going to erase this. I'm going to go x minus 4. Now I was asked a good question when I walked around and say, Mr. No, do I use 4.001 or do I just use 4? Rule of thumb is this. If you can use the number 4, use it. If you can't, then use 4.0001. In this case, I can. And the answer just becomes 0. We say that it approaches 0 so much, I'm going to call that 0 for now. Potato. 4 minus. So now I'm going to use 8 minus 2x. And in this case, it also equals to 0. So you can go ahead and write down your final statement. This is not your answer. Please don't do this and leave it for me to do the rest. This is just your work. Your final answer comes from merging these two together. So we say the lim x approaches 4 of f of x equals to, with confidence, 0. That means as x approaches 4, so close that my value will become really, really close to 0. We call that 0. Next thing, on your homework, you're going to see this symbol lots. This symbol right here, I'm going to teach you some called symbol. It's little brackets with a double bar. I'm going to teach you about this symbol right here. This is called the greatest integer function. Integer function. What this means is this. If I have a number here, 3.14, and I use this bracket, it means find the closest integer smaller than that number. Closest integer smaller than that number. And that's what you get. See, absolute turns negatives into positives. This says this is the largest number you can have. So what's the integer that goes there? So if I put it in, you should have 3. We don't round up. We round down to the nearest integer. So if I have 4.8. Okay, somebody say, hey man, so that's easy, that's 5. Well, this is saying this is the greatest number you can have in here. I want the nearest whole number that's smaller. Joanna, what's it going to be? 4. Okay, that's what it is. Now, I'm going to apply this using calculus. Lim x approaches 3. Greatest integer function, x. What is that going to be? 3. Because if I take 3 from the right, I will get 3. If I take 3 from the left, oh, no, not 3. Do this. Do the left case, right case for me, please. So if I look at this, I can go lim. X approaches 3 from the right. X. And if I do that, well, that's easy, 3. But if I go lim, X approaches 3 from the left. And if I choose a number, say 2.999, that number really ends up being 2. So therefore, this limit is D and E. Okay? This is called the greatest integer function. It means this is the highest number. Choose a number that's greatest integer that is same or lower. Can't have anything bigger than that. Last thing I'm going to teach you is called the squeeze theorem. I'm going to push it through and then we're done for today. Squeeze theorem. I'm going to show you how to use this. This is a bit tricky. You need to be good with trig to this. And before I can start, I'm going to ask you to draw a sine graph and draw a cos graph for me. Label your y and x axis. So we're going to do a standard sine and standard cos graph. Back in grade 12, you should have done your graphs. Sine graph, cos graph. I'm going to give you 2 minutes. Go. I'm going to pause it. My standard sine graph looks like this. You're going to go back to this and review this if you have to. Up here is 1. Down here is -1. 2 pi, pi, 0. Cos graph starts here. 0, 2 pi, pi, 1, -1. Here is your question. I'm going to teach you something. I'm going to give you a question first, and I'm going to show you how to do it. Find lim. X approaches 0 of x squared sine 1 over x, bracket. In this question, if I sub in 0 directly, it won't work because you have 1 over 0. I can't factor. I can't use the conjugate. I can't expand. So I need to know a new trick. This next trick, this is your fourth trick right here. This is known as the squeeze theorem. Squeeze theorem. Here's how the squeeze theorem works. I'll explain it to you what the formula is, and I'll write it down. If f of x, this is going to be g of x, h of x, when x is near a, and lim x approaches a of f of x equals lim x approaches a of h of x equals to L lim g of x, oops, sorry, lim x of a g of x equals to L. So that is known as the squeeze theorem. Some say, what the heck is that? This formula, I kid you not, it looks insane. And you'll be given this formula in college also. Half of the kids will not know what this is. I'm going to break this formula down to something simpler for you. Here's what this formula says. If, let's say, x, here's x. If I tell you x is a number that is less than or equal to 3, okay? And I also tell you that x is a number is also greater than or equal to 3. What do you think my value for x is? That's a simple game. If I tell you for a fact that x is less than or equal to 3 and is also greater than or equal to 3, what is the value of x? 3. My only answer is 3. Because x, Karn, if you want to step out, step out. Seriously. I don't have places for you here. I have x, so therefore, this is, think of x as being squeezed in between two things. If my thing on my boundary on the right is 3, boundary on the left is 3, by according to law, x has to be 3. So they're saying this. If I want to find the limits, if I want to know what the limit of g of x is, okay, and if I can tell you that for a fact, if it's in between L and L, let's just say this. If my limit is in between L and L, would you agree for a fact that the limit g of x must equal to L? That's called the squeeze theorem. That's what this is saying. This is saying this. If x is less than g of x and less than h of x, and f and h is equal to L, therefore by law g must equal to L. Now so I'm saying, so how do I use this to apply for this? Here's how. I'm going to start off with my question again, lim. As x approaches 0 of x squared sine 1 over x. Squeeze theorem, I'm going to write this down. Squeeze theorem generally applies to trig. Generally applies to trig. So when you say trig, there may be a chance it involves squeeze theorem. Not guarantee applies to trig. Okay? There's just a good chance it works. I'm going to look at the first, forget this x squared for now. I'm just going to look at the sine 1 over x. Sine 1 over x. Okay? If I look at a sine graph, here's my sine graph. The highest point a sine graph can reach is 1. The lowest point a sine graph can reach is negative 1. So why don't I do this? I know that a sine graph is going to be less than 1, but it's also going to be greater than negative 1. That's a fact from what you just draw. But this equation and this equation are different because why? There's this x squared here. That's the only thing that's different between this. So here's what I'm going to do. I'm going to multiply this equation by an x squared. When I do that, I'm going to multiply both sides by an x squared. So this now becomes x squared sine 1 over x is less than x squared less than negative x squared. Agree? Sorry, what's going on? Because I'm multiplying this by x squared to match it up. So now, this question really becomes lim as x approaches 0. If I sub 0 into x, forget the middle part, I just want to see what the left and right boundaries is. Would you agree I get 0 is x squared sine 1 over x 0. Therefore, you can go ahead find out the limit now. Lim as x approaches 0 of x squared sine 1 over x. That equals to a certain number. By law, it has to equal to 0. That's called the squeeze theorem. Squeeze theorem means I force everything into one thing and I squeeze it together so that if my left bound and right bound, therefore my number in middle has to be that. I won't give you any homework. Tomorrow you're going to do this in class. So there's going to be no homework, guys. No quiz.